And now it is revolved around the line x equals -3, making the total diameter of the tornado even larger. So to find the area that's unaffected by the tornado, we're going to use the shell method. So if the tornado is represented by the line y equals √x, and it goes to x equals 36 and then revolved around the line x equals -3, we're going to have a graph that looks like this. So the first step to the shell method is determining what our bounds are going to be. Since the line x equals -3 is a vertical line, it mirrors the y-axis, we're going to integrate with respect to x. So everything in our function is going to be in terms of x. So to start out, we want to pull out the 2 pi. And that's just part of the formula for the shell method. And we've already determined our bounds are going to be with respect to x. So we're going to take the integral from 0 to 36. Now, since we revolved around the line x equals -3, we're going to have the function x plus 3. Once again, that x is just representative because it's mirroring the y-axis, and with the shell method, you need to use everything with x. So since it's -3, it would be x minus -3 or x plus 3. Then you take that function and you multiply it by the function that is representative of the tornado, which is y equals √x. And then we have our dummy variable dx. So our whole integral function looks like 2 pi, the integral from 0 to 36 of x plus 3 times √x dx. So if you want to have even more fun, you want to take the antiderivative. So the first step to taking the antiderivative is foiling x plus 3 times √x. So our new equation is x √x plus 3 √x. Not really equation, a new function, we'll say. So to take the antiderivative of x √x, you need to multiply x to the first times x raised to the 1/2, since the square root of x is actually x to the 1/2. So when you do that, and when you multiply exponents with like bases, you really add their exponents, you get x raised to the 3/2. So using the power rule, we can pull that down, and we can do 2x raised to the 5/2 over 5. And how we got that was we added 2 over 2 to x to the 3/2 and then put it over the same. So when you divide by a fraction, it's the same as multiplying by the reciprocal. So you get, rather than x raised to the 5/2 over 5/2, you get 2x raised to the 5/2 over 5. Now back to our other part of the function, which is this 3 √x. You also need to take the antiderivative of that and add it. So what you do here is you take out the 3, and it's a constant, so you can just pull that out. And you're left with x raised to the 1/2. When you add 1 to x raised to the 1/2, you get x raised to the 3/2. Once again, using the power rule and basically the rule for taking antiderivatives, we then have to put it over 3/2. But rather than having a fraction over a fraction in a complex fraction, we're going to multiply it by 2/3. And when you multiply it by 2/3, the 3 cancels that you originally pulled out in order to take the antiderivative. So now our function is 2x raised to the 5/2 over 5 plus 2x raised to the 3/2. And that is our antiderivative. Now, to find the volume of that, you need to evaluate that function from 0 to 36. So you plug in 36 to that function, get your answer, then plug in 0 and subtract the 2. And when you do that, you get 3,542.4. But don't forget, from up top, we multiplied that whole integral by 2 pi. So we need to bring that down. And to get a more precise answer, what we're going to do is multiply that number by 2 and just stick pi at the end since we're multiplying it. So our final answer is 7,084.8 pi cubic feet, since that is our units, and every single block on the graph paper represents 1 cubic foot.